Good afternoon. Today we are going to be talking about scatter plots and lines of best fit. Our goal today is to interpret points on a scatter plot and to use lines of best fit to make and evaluate expressions. A scatter plot is a graph showing a relationship between two data sets. If those dots on the scatter plot make a pattern, we say that they have a correlation. A correlation is how two things relate to one another. A good example of this is shoe size. You are not guaranteed to have a shoe size based on your height, but on average, the shorter you are, the smaller your shoe size is going to be. The taller that you are, the bigger your shoe size will be. It is not set in stone, but it does have a pattern in general to it. So we have a positive correlation. As you can see, the dots tend to go up, so we call that a positive correlation. If the dots make a pattern where they appear to be going down, we would say that's a negative correlation. And if the dots are all over the place and don't really make a pattern, we say that is no correlation. Let's go ahead and use this as an example. So here it says to draw a line of best fit. So we're going to go ahead and plot these points here. So let's go ahead and we have hours. And then we're going to make our graph. So we have to get up to 9 hours here. So let's start at 0, and every 2 squares will go 1 hour. Okay. And then we have place and race, which if we look, the biggest place we need to get is to 45th place. So let's go ahead, we'll say place. And then every 2 squares will go 5 places. Okay. Now let's go ahead and plot these points. So at 3 hours of practice, you can expect to take about 45th in the race. So let's go ahead. We put a dot at 3:45. With 4 hours of practice, you can expect to take 34th place. So at 4 hours, we're going to go right about to 35th, 34th place right there. 5 hours, so we have 5:30. So we're going to go 5:30 right there. 6:20. 7:15. 8:12. 9:10. And that's all the positions we have. And as you can notice, this doesn't make a perfectly straight line. However, we can make a line that sort of hits as many points as possible. So let's go ahead and do that. Notice it is a straight line that I made. Your line should not be curved. And that would be a scatter plot for us. So let's go ahead and look at our examples here. It says write the slope-intercept form of an equation for the line of fit. Use the points 4,34 and 8,12. So those are 2 points that were on our table right there. So let's write an equation for those. So to do that, we first have to know our slope. So I'm going to say 434 and 812. Let's stack and slide to find our slope. So we have 34, 12, 4, and 8. Make sure to put a minus sign between them. 34 minus 12 is going to be 22. And then 4 minus 8 is negative 4. So 22 divided by negative 4, I can actually use my calculator to do that. So I'm going to go ahead, pop open my calculator here. And if I look, 22 divided by negative 4 is negative 5.5. So my slope is negative 5.5. So now I can put that into point slope form. I'm going to use 434 just because it really doesn't matter. It's your choice. So I say y minus 34 equals negative 5.5 x minus 4. So I have y minus 34 equals negative 5.5x. 4 times negative 5.5, if I pop open my calculator, 4 times negative 5.5 is going to be negative 22. So minus 22. Now all I have to do to finish this off is add 34 on each side. So I have y equals negative 5.5x. Add 34, negative 22 plus 34 is going to be positive 12. And that is my slope-intercept form equation right here. Okay, so we want to predict the place in the race after 2 hours of practice. So if I look on my chart, there's actually 2 ways to do this. You can either use the equation or you can look on your chart. So if I look on my chart, after 2 hours of practice, my line's right about there. You could expect to take about 47th place. So I'd say 47th. What type of correlation is this? I would say this is a negative correlation because it's going down. Let's go ahead and look at our next problem here. Next up, we have regression. So regression is a graph showing a relationship between 2 data sets. Basically, it is how straight of a line do your dots make. So we have a couple options here. We'll go ahead and erase this. So if the closer the value of r is to the absolute value of 1, the better the equation fits the data. So if your dots lined up to make a perfectly straight line, you would say they have an r value of 1. If your dots are just scattered all over the place, they would have an r value of 0. Your value will always be between -1 and 1. Now, we have written this in words. I'm actually going to put some dots on the page to kind of show you what I mean. So if you had dots that went in a perfectly straight line, you would say your r value is close to 1. If you had dots that were going down in a perfectly straight line, you would say your r value is close to -1. If you had dots all over the place, like so, you would say your correlation is 0. So nothing too difficult. Okay, let's go ahead and practice that. So it says draw a plot that has a regression value close to 1. So that means as we want it to be kind of a straight line, if we look, something like this would have an R value of close to 1, because as you can see, the dots are going up in a fairly straight pattern. So we want something that is close to 0. So I'm just going to put dots all over my page here. And as you can see, there is no real pattern to how I'm doing it. The dots are just sort of all over the place. So we would say our regression value is close to 0. That's it for today's lesson. Have a great rest of your day.